good afternoon, good evening, whatever the case may be. We are back and better than ever for part 2 using the sine and cosine rules. Still rocking it with the great Dave's Faves produced by Darby Foster. Let's get to our last example, shall we? All right, we got some hikers. Ritva and Esko leave point P at the same time. So I'm going to put, I don't know, point P right here. Ritva walks on 4 kilometers on a bearing of 040 degrees. Time out. What's bearing? Bearing is degrees clockwise from north. Okay, so you know north, south, east, west. So if he's on a bearing of, I feel like Ritva is a female's name, I'm not sure, on a bearing of 40 degrees, that means you're facing north and then you rotate 40 degrees like this and you're going to walk that way or sail your boat or fly your airplane or whatever. So that is 40 degrees, 040, okay? Different than our trigonometric unit circle, so you got to be careful. All right, so let's see. 40 degrees, so I don't know, that's about like that, and they walk 4 kilometers. So I'm going to label this 4, okay? Then a further 6 kilometers on a bearing of 155 degrees. So I want to put in here that this is 40 degrees, by the way. And so, because that's from north, right? So let me put in another north marker here, okay? And let's think about my bearing. My bearing is 155 degrees. So if I start due north, I rotate 90 degrees. This would be 180 degrees straight down. So 155 is about like this. She walked further, about 6 kilometers. So I'll make it a little longer. So this is 6 kilometers. Okay, and I need to put this closer. This is 4. And I know that this angle right here is 150 degrees. Okay. Esko hikes directly from P to the campsite. So this is the campsite right here, because that's where Ritva was going. And so that would be, I'll put him in blue, Esko. I'll put him in blue, Esko. So he goes this way. There we go. Okay, and then the question is, how far does Esko hike? So we are looking for this value, x. Okay, so I'm going to find that. So I look at it, and I know that if I can figure out this angle here, I can use the law of cosines to find the value of x. And actually, I can do it fairly simply. Let's go to blue here. A north direction is parallel to another north direction. And I know that this is 40 degrees. And I know from geometry that same side interior angles are supplementary. That is, they add up to 180 degrees. So that means this angle here must be 140 degrees because 140 plus 40 is 180. Okay, so now I can get this angle because all the way around is 360. So I take 360, just a little scrap paper here, minus 140 plus 150. You can almost do it in your head. 360 minus 140 plus 150. Oh, wait a second. That is supposed to be 155. My bad, my bad, my bad. 155. So this is 155 right here. Ooh, all right. If you had a better teacher, you would have known that. So 360 minus 140 plus 155 is 65 degrees. And now I can use the very awesome law of cosines to say that x is equal to the square root of 4 squared plus 6 squared minus 2. times 4 times 6 times a cosine of 65 degrees. You crank that in your calculator and you get x approximately equal to 5.63 kilometers. Trust me on that one. So that's part A. Let's look at part B. In which direction does S go height? So what they want is the bearing, okay? So if you think about it, ESCO went like that, okay? So we already know from here to here, let me color that in, is 40 degrees. But I need this angle, and I'm going to call it theta of this triangle, okay? And now I can use the law of sines to help me find it. So I am going to say that sine of theta over 6, opposite, is equal to the sine of 65 degrees over x, which is 5.63. And so then theta is approximately equal to the arc sine. If you do cross multiplication, 6 sine 65 over 5.63. Bam, bam. And so I get theta approximately equal to 74.9 degrees. There might be a rounding error there, but it should be close to that. So that means his bearing for ESCO is the 40 plus the 74.9 degrees, which is 114.9 degrees, which is about 115 degrees, whatever. Okay, so that is his direction. That is on a bearing of 115 degrees. So, part C. Ripka hikes at 10 kilometers per hour and Esko hikes at 6 kilometers per hour. Who will arrive at the campsite first? Well, that's not too bad, right? We know that distance equals rate times time. Let's get rid of this so I have a little more room. See, distance equals rate times time. So we're looking who got there faster, so we're looking for time. So time equals distance over rate. So then for, let's see, for Ritka, that would be equal to 6 over, well, because her, oh, no, it's not 6. She went 4. So for Ritka, she hiked 4 and then 6 for a total of 10 kilometers. So that's going to be equal to 10. And divided by her rate is 10 kilometers per hour. So it takes her 1 hour. And Esko, he hiked, what was our distance? 5.63 kilometers. But he hiked at a slower rate, I believe. Yes, he did, which is 6 kilometers. That's clearly less than 1. And that's about 0.9386 hours. So it took him less time than Ritka. So Esko is our speed demon. Attaboy Esko. And then, let me erase this. So maybe I can do D there. So here's campsite. Campsite. Part D. Oh, how long will this person need to wait before the other person arrives? Well, that's silly. I mean, it's just 1 hour, 60 minutes. That's 0.96386 hours. So if I did 1 minus 0.9386 hours, that is approximately point, what? 0.0724. Yep, 724 hours, and that converts to about 3.68 minutes. So that's part 2, 3.68 minutes. Okay, so the 1 minus the 0.9386 is 3.68 minutes. On what bearing should the hikers walk from camp to return from P? All right, here we go again. All right, so what do we need here? Okay. Well, if I think of north, well, I don't think of north. This is north, so they would have to go. If I can find this angle, I'll call it alpha right here. Then I can easily find the bearing, because remember, bearing is degrees clockwise from north. So I need to find alpha, okay? Well, this is not too bad. So again, north here, north here. So this big giant angle and alpha have to add up to 180 degrees because they are same side interior angles to parallel lines. So I just have to take 180 minus the sum of 74.9 and 40 degrees, which is 114.9, which that is equal to 65.1 degrees. But remember, bearing alpha is 65.1. So bearing is the other way. So to find this whole big giant angle, I just take 360 minus 65.1 degrees, and I get about 295 degrees, okay, after you round it. So that's their bearing. This is 290, well, let's say 294.9 degrees, and we rounded it to 295. So their bearing would be 294 or 295 degrees rotated clockwise from north. Okay, that was a whole lot, but, not that bad. Each individual part is not that bad. You are more than capable of it. I hope that you enjoyed it. And with that, we're going to listen to Flirting with Disaster, and I am out!